Okay, so in this demonstration, I'm going to use the A rules package to do association rule mining on the shooting dataset. So I have called for those libraries that we're going to use. A rules is the package for association rule mining in R. We're also going to use visualization package later. But for now, we just called A rules and a deep layer. So now go to my folder and load our shooting data. And remind you, this is the shooting data that we have cleaned, we pre-processed, we discretized. So those are the attributes we currently have. So the data we currently have is in a data frame, but we know association rule mining expects transactions. So we need to convert our shooting data to a transactions data format. The transaction data format here, as we're going to see, it's basically using the bitmap indexing or the hotwire encoding to actually convert those attributes into a set of binary variables. We're going to see how that conversion is done here. So if your data is already binary encoded, 1 and truth or 0 and false as values, you don't need to do this as step, okay? Because a rules methods accept bitmap matrix or data frame converted to transactions. Okay, so let's do this. And I know that this error going to occur. If this error occurs, all you have to do is to just make sure that your data is actually in the data frame, because we have added things and convert things. So our currently the type of our data is a special table and data frame. So we want to put them into a clean data frame format. So let's do this as data frame. Oh. So we need to convert that to data frame. And then, well, I typically would like to, yeah, that's correct. Because we want to keep the shooting data intact. Any change should happen in a new variable. So we're going to convert to that. And then we're going to convert, our data now is converted to a transaction database, but we got a warning message saying this many columns are neither not logic or factor. So the system applied some default discretization method to make them factors. That may not be desirable, so what I want to do is to actually do that conversion myself. So look at all the columns we currently have. This is going to show you after the conversion, you can see that our data is all converted to bitmap. Every value is converted to a attribute, a column. And we notice right here that name is not a good thing to convert to bitmap entries, because that will give us too many. It will make our transaction dataset too sparse. And you will see that after we removed some of the columns, our transaction dataset is still very sparse. So that's not very good for association rule mining, because we want to mine those regular frequent patterns, right? So that reminds us that name probably isn't a good thing to keep, and some other columns with high cardinality should all be removed too. So now let's see what attributes we have and how are we going to deal with those. So here are the things that we currently have. We can see ID is definitely unique. Name is almost unique. We don't want them. Date has been split into year and month, so we don't need date. Manner of death is good. Armed remember we converted armed to armed types. Armed type, yes. So we're going to use armed type and not armed. Age, we have also age group somewhere, age group, therefore we don't need age. We need gender, we need race. City is too diverse, so we can remove city. And we'll keep state. Sign of illness is good, threat level is good, flea, body camera, those are all good. But poverty level, VP ratio, and VP ratio level, poverty, that's population level, this is poverty level. All those four were generated based on the state information. So I have first to keep those. So I removed the high cardinality attributes and keep pop level and all those four attributes, and I ran the rules once, and I found that this set of things are distracting because all those four attributes were derived from state. So they often co-occur with state many times, making the rules very tedious to read. So I decided in this run, I'm going to remove those. But in my first run, I also tested the correlation because I was thinking whether we want to keep off all of them. So even though I decided in this run not to use this for attributes, I still want to show you those correlation tests. Earlier, we ran chi-square test. Remember? We learned chi-square test. It gave us chi-squared critical value and the p-value. We know this correlation is significant, but we don't, since chi-squared does not have an upper bound, we don't know how strongly that correlation really is. So both of them seems to are correlated, but we don't know how strong that correlation is. So I'm going to recommend you another package called R Companion. And this in this package, we can use Cramer's V to actually do nominal variable correlation analysis. This is going to give us a value normalized between 1 and 0. So we can see how strong this correlation is. It's very like Pearson's correlation, the value. So when we look at both, they're not highly correlated. They're weakly correlated. So in my first run, I decided to keep all of those. And it turns out to be very difficult for me to interpret the rules. There are a lot of rules, and a lot of rules carry redundant information. So therefore, in this run that I'm going to show you, I'm not going to include those. I'm actually going to remove all those columns that I mentioned here. So I remove those and create the new shooting transactions data frame. And we can see that the current column now are the original columns names with some of things discretized and high cardinality columns removed. So now I need to convert those things into characters to factors. So there are 3 different ways that can be used to do this. I have found that this is not a reliable way. If your data frame is actually freshly created using that data frame, this would work. If your data frame was actually being processed multiple times with lots of modifications, this on-class and the data frame approach does not always work. So I have decided to use either of the following 2 methods. So using this pipe, we can actually convert all the characters, so mutate. If a column is character, mutate it to factor. Okay, so this is how we're going to, we did the mutation. And at this time, because our year and month was number, so they were not converted using this line. I need to specifically convert those two columns as factor. So I did that. And now when we look at our transaction database, we only have factors and the logic data types. Okay, so now we can actually do the real conversion, convert the data frame to transactions. Okay, so we encountered exactly the same issue that we have before. So did you remember what the solution is? So shooting trans, let's make it a clean. Let's run this and run this. Okay, so now the system is happy. Okay, so now we have the transactions, and now you must be curious what is in this shooting trans, this transaction dataset. So, so I told you it's not the shooting trans because it's a very sparse matrix. It's very hard to view it in its entirety. So we want to do a summary and see what's inside. It gave you lots of information, so we can see this matrix has a density of 0.1. So 90% of the data cells in this large matrix is empty or with a value of 0. Okay. So why is that? Because we did bitmap conversion. Only the values that occurred going to have a value of 1, all the rest are going to have a 0 in that matrix. We have this number of rows. That was the original number of observations in our dataset. And now our columns has increased to 99 columns. So what? How do we get from, I think, 10 columns to 99 columns? Remember, every value, unique values in a column is going to be converted to a new column in the matrix. So this 99 columns is actually the sum of all the factor levels of every factor. We have many factors plus the 2 logical attributes. So that gave us 99. Density is computed by the number of cells holding 1, or the true value, divided by total cells. As you can see, our matrix is very sparse. Additional information, the system tells us the most frequent items that in the converted matrix, we have gender to be male. A lot of times, almost all of the 4,200 cases. Manner of death, mostly a shoot. Majority cases not fleeing. Threat level is attack, so it gave you some most prominent, most frequent values in the dataset by columns. So the element length distribution, this is how many items is in one transaction. So we have 32 transactions holding 12 items. Okay. And here we have the distribution. The median length of a transaction is 10. So we have 10 zeros. And here are some examples, and we can actually look at those examples in more detail by using the inspect. Oh, do we want to look at the column names first? We can do that. So the column names does not surprise you, right? It's just a bitmap conversion. And if we look at inspect the first 10 transactions, we can see So this is the transaction ID. This is the transaction. So this transaction holds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. Okay, so this is one of the records that we had. So now with the data is ready for us to do the mining, and we will start to mine. A priori method can be used to mine different things. It can be used to mine frequent item set. It can be used to mine the rules. It can even be used to mine closed rules or maximum. So let's start by using frequent item set. So this is our input data. We need to tell the system some parameters. So the key element that we tell a priori obviously is support. Why do we only tell the system support, not confidence? Because we currently only mine frequent items. Frequent items, whether item is frequent or not, is determined by the support only. So confidence and other things measure the rules, measure the strength of the rules. So let's do this. We create a set. As you can see, we have 1100 frequent sets. That's too many. I don't even bother to review them. And we can actually let the system to find the closed set, select a closed set item set for us. So we do closed, and we summarize it, and we can see we still have a large number. Actually, we have exactly the same number as the previous. So all the frequent sets that we mined before were actually closed. So still it's too many, but you can certainly inspect it. So what I did is to inspect closed set. The top 5 will be displayed, and we're going to sort that top 5 by its support. So this is going to give us, so we can see mail is most frequent occurring. None of the transactions in our database actually is identical to this item set. As you can tell, our transactions have multiple attributes, and this item set holding one item only. So you'll see a set of zeros, and this is raw count, the occurrence or the absolute support. Okay, so now we can actually, from our set, select the maximum frequent item set. This often reduces the item set by a lot. So now we only have 141. So now we can inspect the maximum. Remember, what is maximum frequent item set? Those are the longest frequent item set. Adding any new item to this item set will make this new item set not frequent enough. It will drop below the support threshold. Okay. So what we see here, so earlier when we look at the summary, the maximum summary that we gather in the frequent item set is only 0.808. So as you can tell, now we have those high support items listed. So those give us the most typical cases in the shooting data. Most typical cases are the shooting happens involving a male victim, a white male victim. The threat level is other, and victim was not fleeing. So those are the most typical cases. Some other typical cases that you can also examine. What draw my attention is actually month. August and the year 2016 showed up in some of the most frequent patterns. So I wanted to check whether month 8 is actually something special, or 2016 is something special. So I did some plot. Let's run this. So we see actually 2016 does not have a lot of cases compared to other years. But when you add gender male and shooting and others, 2016 seems to be a bit special than others. So this may be something worth further investigation. Similarly, when I run months, you can see the total counts in incidents happened in August. It's actually not that many compared to others. So then, however, when the shooting happens, the manner of death is shot, and the gender is male, then seems like August is more frequent time for those incidents to happen than others. So this may also be another interesting to investigate, which we will not do in this video, but those are the things that might actually shed more insights into this data mining task. So as I mentioned earlier, we can actually obtain maximum frequent item set directly. And I'm going to run this, but just let you know that the result, whether you run it directly or mine the raw set and then select a maximum set, they're going to give you the exactly same result. So we can run this, and we see 141 sets was found. And if you summarize this and inspect this, you're going to see exactly the same result as we did before. So I want to, since we're race is one of the major things that we concern when we mine this data set, so I want to see whether any of these frequent items actually contain race. So this is the selection methods that we can use to select from maximum frequent item set or from any frequent item set, select a subset. The condition is the items actually contains race equals B. Okay, so we can run this and found, okay, there is 7 cases. If I change this to Asia, I have 0 occurrences. So because A happened too infrequently. So I'm going to keep this. We're not going to look into those rules as of now, but later on, we're going to actually look at those rules involving race. Similarly, you can run this and find that closed item set is exactly the same as we first mine the raw set and then select closed set. Now, finally, we can actually start to mine the rules. So besides mining item sets, you can actually say, I want to mine rules directly. When you mine rules, you will have to give the system two threshold, the support and the confidence. And the minimum length of 2 is needed because a priori this method only creates rules with 1 item on the right hand side. So we need to tell the system to only find rules that has a length of 2 or greater, to avoid rules such as this, empty things are to bear. Okay, so let's mine this rule, and we'll see there's a lot of rules. 2800. Okay, there's no way we can read 2800 rules. So I have included also a line here to prove what I said here is correct. That a priori only create rules with 1 item, because if we use very low support, very low confidence, we can extract almost all the rules. If we ask inspect a subset of the rules with the condition of the right hand side greater than 1, so the length of the right hand holding more than 1 items, we won't get anything, because a priori will never mine those rules with more than more than one item on the right hand side. Okay, coming back, because here we have this rules is too many, and so we want to actually use this selection criteria to find the rules that are generated from maximal frequent item set. So I'll do that. This will greatly reduce the number of rules that we're going to have. Still kind of big, over 400 rules. Well, this video is getting long. Let me terminate the video here and start a new video to continue with the inspection and the visualization of the rules.